In this lesson, we will learn about the Active Directory components that are responsible for generating replication connection topologies. First of all, we will learn about Active Directory database, then Directory System Agent, and after that we will learn about connection objects, knowledge consistency checker, then Intersite topology generator, and Bridgehead server. And finally, we sum up our lesson with the keynotes. As you may know, HDC stores its own Active Directory database ntds.dit in the local hard drive. The database has up to 4 partitions: schema partition, configuration partition, application partition, and domain partition. These partitions must be in sync among all the DCs in an ID forest. That is the reason why Active Directory must build replication topologies to synchronize these partitions. Directory System Agents is a collection of services and processes running on HDC to provide interfaces for external applications to interact with Active Directory database in a control manner. The DSA handles directory operations such as searches, modifications, authentication requests. The DSA also initiates and responds to replication requests. To allow a local DC to get updates from a partner DC in an ID forest, there must exist a one-way connection object from the partner DC to the local DC. The combination of all connection objects constructs replication topologies to synchronize Active Directory partitions throughout the entire AD forest. Connection objects can be either created manually by system administrator or by an AD process called knowledge consistency checker. Knowledge Consistency Checker, or KCCs, is a built-in process running on HDC. It works like a routing protocol to generate and maintain replication topologies for both intrasite and intersite. The KCC connects to the replication subsystem interface provided by DSAs to gain access to the configuration partition to read the forest-wide configuration data in the ID forest, which allows the KCC to generate and maintain replication topologies. Based on the forest-wide configuration data, each KCC figures out the list of all DCs in each site and form partnership with other KCCs in the same site in a ring topology. Each KCC in the ring creates inbound connection objects, which has its local DCs as the destination and the partner DCs as the sources. KCCs in a site elect one of their DCs to become an Intersite topology generator, or ISTGs, to manage replication topologies between sites. The ISTGs analyze the site bridges, and transport protocols to determine the most efficient routes for replication traffic, which allow it to select one or more DCs in the site as bridgehead servers based on the performance, availability, and load of the chosen DCs. So in this side, this DC is elected as ISTGs and it selected this DCs as the bridgehead server of the site. In this side, this DC is elected as the ISTGs and it selected these two DCs as the bridgehead servers of the site. And in this side, this DC is elected as the ISTGs and it selected itself as a bridgehead server of the site. The KCC in a bridgehead server of a site considers itself as a destination and creates inbound connection objects with bridgehead servers of other sites as the sources. As you can see, bridgehead servers enable replication for domain controllers in different sites in the same ID forest. This is the end of this lesson. Let's read the keynotes.